Hi everyone and welcome back to my channel. We'll be taking this example on 01 knapsack problem. So you should pause this video, read the question, understand it, and get right back. If we were using a greedy algorithm to solve this problem, this is what it would look like. Where our maximum knapsack weight is W. The first thing we want to do is to sort all the items in non-increasing order of profit weight ratio. That's just as it said in the question, VI over WI. That's profit weight ratio. Then we want to initialize our total weight to 0, our value to 0, and an empty list for the item selected. So we pick the first item in the sorted order with weight WI. If the total weight we already have plus the weight of that item we are going to pick is greater than 0, we drop the item, then we go to the next item. If the total weight we already have plus the weight of the item we want to pick is equal to 0, we pick it and then stop. And whenever we stop, of course, we want to update the total weight, value, and item selected. If the total weight, that's the weight we have already, plus the weight of the items we want to pick is less than W, we pick it, we update the total weight, value, and item selected. Then we go to the next item in this sorted order. Then we repeat all the steps that I've just mentioned, the 3 steps. The 3 steps being, when we pick an item, we check the total weight of the items we've selected already plus the weight of the item we just picked. If it's greater than big W, that's the capacity of the knapsack. If it's greater than it, we drop the item. If it's equal to the knapsack, we pick it and stop there. If it's less than it, we pick it and update the total weight, value, and item selected. We do this repeatedly until we get to a weight either equals the knapsack or greater than the knapsack. So let's take an example. Give an example. The question says to give an example where this greedy algorithm does not return the optimum solution. So let's say we have items. This is the example. Let's say we have items A, B, C, D, which have weights 5, 10, 15, 20, and have values 13, 50, 60, 80. This means that your profit weight value would be 6, 5, 4, 4. Profit weight value would be value divided by weight. That's 30 divided by 5, 6, 5, 50 divided by 10, 5, 60 divided by 15, 4, 80 divided by 24. So let's imagine we have items that have all of these values. And let's also say that knapsack has value 25. So here, our greedy will choose items with weights 5 and 10. That's items A and B. Remember, we already organized or sorted our items in order of increasing weights. So if we were to use the greedy algorithm, it would just grab items A and B. That's items with weights 5 and 10. And when you add this, it gives 15. And that's because if items A and B, using the greedy, if we're going in ascending order of weight, it gives us value 80 of profit. If we're going decreasing order, it would grab only D. D has weight 20 and its value is 80. So if we go in increasing order, in ascending order of weight, you just get to grab more items, but the value remains the same. But this is not an optimal choice. If we selected A and D would have we'll fill up our knapsack to capacity. We'll have weight 5 plus 20, that's 25, and our value would be maximized. That's 30 plus 80, that's 110. When we pick items A and D, we have value 30 plus 80, that's 110, and this is our optimal choice. So we see that the greedy algorithm does not give us an optimal solution for this problem. We are going to stop here, and in the next video we'll grab more examples on these kinds of problems. See you on the next one.